You can argue that we are at the center, that there is nothing like us, that we are unique and special. But if we have neighbors, it won't change. You will just be illusioned. And nobody should bet against Elon Musk. And that gave me the idea to bet against Elon Musk. Maybe the Big Bang was produced by a quantum gravity engineer.
Hello, everybody. Welcome back to Watch Mojo and the Unveiled podcast, where we bring you interviews with leading experts on UFOs and UAPs. I'm your host, Rob, and today I have the pleasure of speaking to Harvard professor Avi Loeb. He is the head of the Galileo Project and the best-selling author of the books Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Professor Loeb, thank you so much for joining us today.
Thanks for having me.
So you've been very vocal in recent years about the importance of searching for alien life in the universe. Why is this so important to you?
Oh, it will affect the future of humanity. I mean, currently we're spending $2.4 trillion on military budgets worldwide, mostly to kill other people or prevent them from killing us. And that's a very down-to-earth investment that makes no sense whatsoever in the cosmic scheme of things because there is much more real estate beyond Earth. And if you just look up instead of down, you realize that, we're minor actors on the cosmic scene. And most stars formed billions of years before the sun. So we are late to the party. And moreover, a significant fraction of them have a planet like the Earth. At least a few percent have a planet the size of Earth, roughly at the same separation. And that means that there could have been things like us billions of years ago throughout the Milky Way galaxy. Maybe they died by now, but they may have witnessed much more advanced technologies than we currently possess because we only had 1 century of science and technology. And recognizing that will first of all install in all of us a sense of humility, which we desperately need, given that religion is not important as much as it used to be, and we lost the sense of awe. We are quite we think that we are at the top of the food chain, but that may not be the case. And so that's a very important thing that we will realize that we are not at the center of stage. There is someone else that we can learn from. But more importantly, we can be inspired to develop new technologies, new science. And it's just like Moses in the Old Testament met or witnessed the burning bush that was never consumed, and that convinced Moses that there is a superhuman entity that he started believing in, which was God. And if we were to show Moses today a cell phone, he would have been more at awe than from a bush that is burning, and moreover, this cell phone would have helped him to reach the promised land much faster than 40 years because it would have GPS system and navigation. So at any event, it has nothing to do with a superhuman entity. That's just a more advanced technology that allows us to use cell phones and GPS systems rather than whatever was used back then in the desert to figure out the path to the promised land. And so what I'm saying is that, if you imagine something that is more than 100 years old technology or science, it would be awe-inspiring and we could, learn a lot. It will give us a quantum leap into our technological future. And so there is so much benefit, both in terms of our culture, in terms of our sense of humility, in terms of our science and technology, that this seems to me like the most important question that science can address. So you would think, well, after everything I said, that this would be obviously a major research area in academia, and obviously most funding will go into that direction because of the huge implications. The answer is no. In fact, it's considered completely peripheral to any academic research done right now in astronomy or in physics. It's not funded at all by federal agencies. And by at all, I mean that the funding is at most a few $100,000 out of, compared to $10 billion that are allocated to major scientific projects like the Webb telescope or or the Large Hadron Collider. So it's completely ignored in terms of federal funding and completely sidelined by scientific researchers. And the question is why? How? And one possible answer, which is quite simple, is that common sense is not common in academia.
Why would that be the case? If these are we're talking about the smartest people on Earth, so why would they not be interested in something like this?
Because, well, it brings some risks that you might not find anything, but at the same time, that's not a good explanation because we don't know what most of the matter in the universe is. We call it dark matter. And over the past 50 years, scientists invested billions of dollars in the search for dark matter without finding anything. So here's an example of the mainstream allocating major funds towards a search that produced nothing. We don't know what the dark matter is, the type of particles. We try to detect it. We try to look for any signatures of its nature, and we haven't. It doesn't interact with matter, ordinary matter. It doesn't interact with light. So anyway, that's an example of a scientific frontier where uh, we were not successful, but yet nobody regrets investing those billions of dollars. So it's clearly not the risk aspect. Um, I think it has a lot to do with the fact that the public cares so much about this subject that there is a lot of talk that makes no sense about it, including science fiction that violates the laws of physics, including people who declare that they were abducted, included people that have some very strong personal beliefs and express their views very strongly. So some people in academia say we don't want to touch this. It's completely radioactive in terms of being contaminated by belief systems and unsubstantiated claims. That why would we get in bed with those people? We don't want to touch it. Um, Now, this is also not a good argument because if you look back at the history of science, there were subjects like that. Some people argued 1,000 years ago that the human body has a soul, and therefore it shouldn't be dissected. There shouldn't be any operations, medical operations, because then you would hurt the soul of a human. Gladly, the scientific community did not listen to that, and we have now modern medicine where you go to the hospital and you can go through an operation that will improve your health and wouldn't affect your soul. As long as they don't touch your brain, you're fine in terms of your soul. So that's an example where not listening to nonsense allowed science to make progress. And the fact that scientists were willing to deal with it without being deterred by the nonsense is a good example for how science can make progress without, attending to all kinds of stories that people invent. So I think it's possible to do scientific research on unidentified anomalous phenomena, on objects that are near Earth. And that's what the Galileo Project is doing. Because, even if 1 in a million of these objects uh, came from another civilization, we will learn a lot. And by saying we don't want to touch it, we will not know that. So it's a way to maintain our ignorance by not doing the scientific research. And that's not the way science should be done. It should be guided by evidence. And the thing that a lot of scientists miss is that new knowledge doesn't fall into our lap. You have to put money, you have to put effort, and that means you have to allow the research. So by people saying, "Oh, it's an extraordinary claim to imagine something like us elsewhere," we don't have the evidence. That's not a good argument because you have to work hard to get the evidence. If you are saying in advance we don't have the evidence, therefore we should not work on collecting the evidence, we should not fund the research, then you will never have evidence. You will stay ignorant about this question, and obviously you will be happy because you would say, "I still don't have evidence." It's sort of like what the church was saying about when Copernicus suggested that the Earth is not at the center of the solar system, it's the sun. And they just dismissed this idea. They used his model to calculate when Easter takes place, but they dismissed the idea. They say, we know that the Earth is at the center. But what good did it bring? I mean, in 1992, they had to admit that he was right, that Galileo Galilei was right. In 1992 was 2 decades after humans reached the moon. I mean, the church, the Vatican, it was a bit late to admit that. But my point is, you can play delaying tactics by saying, "Oh, we don't need to look for any evidence. There is nothing." So, and they had the view that didn't require any evidence because they knew the answer. But eventually, so many scientists collected data on the solar system that it was beyond any reasonable doubt. If we were, if scientists in the Jet Propulsion Lab, as Catholics, were to argue that the Earth is at the center, and they would send a rocket towards Mars. That according to their belief system, based on the Vatican, they would believe that Mars goes around the Earth. The rocket would never reach its destination. Okay, so it doesn't really it doesn't make sense to object to evidence or not to collect evidence because you have a prejudice, simply because reality is whatever it is. You can deny it, but it stays the same. You can argue that we are at the center, that there is nothing like us, that we are unique and special. But if we have neighbors, it won't change. You will just be illusioned. And so I think that the current situation is misguided. And gladly, the Galileo Project is funded by donors who think alike. And we can talk more about what we have done so far.
Yes, absolutely. But before we do, just want to address that, yes, there seems to be a stigma against legitimate scientific studies about UFOs and UAP. But I'm wondering if that sentiment is starting to change a little bit with the increased legitimacy that it's being given by governments and military people and videos and things, censored data that is being released by whistleblowers. What are your thoughts on those, particularly in 2017, the New York Times article, which came with admissions about programs from the Pentagon studying UAPs and videos and whatnot. Do you give any credence to those things? What's your opinion on what we've seen so far from official sources?
Well, the government certainly has evidence about objects that they do not understand. Okay, so the only question is whether this evidence is circumstantial or it's very solid. And we haven't seen the best data. We've seen only videos that were leaked. They're not fully convincing from my perspective. We don't know what the camera was doing at the time they were taken, and we don't know the distance of the object being monitored. So there is enough uncertainty about the parameters of the data that they released for us to call into question whether these are really extraterrestrial or not. And on the other hand, there were eyewitness testimonies, including by David Grush, that the government has much, much more, that there are secret programs for retrieval and reverse engineering of craft, and that they have material evidence. And of course, I would love to know more about it. Not enough detail was released to convince any scientist. But uh, because I mean the reason is quite simple. If they have something, it would save me a lot of time. Means I will not need to work hard to collect similar data. Of course, we don't need to rely on government because the sky is not classified, so we can collect it ourselves. But it will take time. The government is monitoring the sky, the ground for any any objects that might be a national security risk. So they do it routinely. The astronomers are not doing it because most observatories are just looking at a small fraction of the sky and at any given time, and they usually focus on very distant objects. They ignore anything that flies overhead. So this is a regime where the government might be the first to detect something. And so I can imagine they have data that is interesting, but since they are not sharing it with me, I cannot say more about it. If they will share it with me, I could help them figure it out. I think there must be data that they don't understand, that's for sure. Uh, but the question is, what does it represent? Is it technologies developed by adversarial nations that the US is not aware of? Or is it beyond any reasonable doubt extraterrestrial? And in order for me to judge whether it's one or the other, I need to have access to that.
Right. If there were aliens visiting Earth, do you believe that they would have technology sufficiently advanced to be able to evade detection completely if they wanted to?
For sure. I mean, astronomers right now have measured the mass budget of the universe. And out of the 100% of the content of the universe, 70% is called, right now, called dark energy, meaning we don't see it. It has very unusual properties. It's triggering an accelerated expansion of the universe. So it actually, this substance is actually producing negative gravity, repulsive gravity, because objects that are receding from us as a result of the cosmic expansion are accelerating with time. They are moving faster and faster as they move away from us. Just think about Isaac Newton that realized that gravity is a force by seeing an apple fall from a tree in the orchard that his family owned in England. But if instead the apple was not close to the surface of Earth, but somewhere in the universe, you would see the apple going away from you, receding from you at a faster and faster speed, as if gravity is repulsive, which is really strange. That's dark energy. But then on top of that, about 25% is called dark matter. It's matter that is not similar to the remaining 5%, which is the stuff that we are made of, that is visible and we are familiar with in the periodic table of elements. And there is 85% of the matter, which is 25% of the total mass budget of the universe. 85% of the matter that is not interacting with light or with ordinary matter, and we don't know what it is. So now think about another civilization of scientists that on exoplanets that realize what dark matter is or what dark energy is. They could potentially generate communication signals by waves of dark energy that we would not be able to detect because we don't know what it is. They could also use the dark matter as fuel or as material for constructing spacecraft, and we would not see it. So these are just examples. Since we don't know what these constituents are, we can't tell whether you can engineer them. They could also use dark energy in principle for propulsion. If it produces repulsive gravity, you might be able to produce an engine that does not use fuel the way we do in rockets. And so I would say the sky's the limit in terms of what technologies we cannot imagine. What I described is actually the known unknowns in the universe, but on top of that, there could be unknown unknowns. And, it's possible there are things around us that we don't notice. One thing I published a paper about was, what if there was an object that is very massive, let's say 1 million tons or 100 million tons, that is passing near Earth. It's completely dark and it's passing near the speed of light. Such an object would produce enough of a gravitational signal just by the tidal force that it generates. Like the moon is generating a tide on the oceans, and any object produces gravity, a gravitational signal. There is no way to avoid it. You can't mask it. So if there was a dark object, completely dark, stealth object of some technology or whatever, it doesn't matter. If it would pass close to the speed of light near Earth, it would have generated a signal, gravitational signal, that would have been detected by LIGO, the gravitational wave observatory that we have. So we can say with certainty that no object more massive than about 100 million tons passed close to the speed of light near Earth over the past decade, because LIGO would have detected it. But we don't necessarily expect such a massive object. It could have been a spacecraft much less massive, and also we don't expect it to move necessarily close to the speed of light. It's just that if it moves much slower, then the gravitational signal would not appear in the frequency range to which LIGO is sensitive. At the speed of light, you cross the radius of the Earth roughly in 2% of a second. When you take the inverse of 0.02 seconds, you get 50 hertz, which is the frequency to which LIGO is most sensitive. That's why you need an object to move very fast. If it were moving much more slowly, then in principle, in the future, we will have another observatory for gravitational waves called LISA in space. And that could detect actually slower moving objects and lower mass objects. So what I would say is that once we develop technologies that detect gravitational signals, we could potentially find things that are otherwise dark, that are invisible electromagnetically.
Does this help explain the Fermi paradox? We often hear about that, how with the number of stars and planets that exist in the universe that could support life or probably support life, where is everybody? How come we don't normally encounter other civilizations, other beings? Although some would argue that maybe we do, depending on how much you believe in the UAP, narrative that's happening right now. But what's your take on that?
Well, I have two very simple solutions to the Fermi paradox. One is, and I mentioned it in my TED talk a year ago at Vancouver. One is that the aliens are addicted to digital screens, just like we are now, and they don't care too much about physical encounters in the real universe, and because they live in their virtual reality. It's sort of like being addicted to a recreational drug or something. And you just don't care about the physical reality that we all share. The other possibility is what you often tell a lonely person. I also mentioned that in my TED talk. When someone tells you, "Where is everybody?" What do you say? You say, "Well, don't think that you are that attractive, that everyone will come to you. Don't be so presumptuous. It's quite arrogant to say, okay, I'm right here, right now, and I don't see anyone around me that is a potential partner for me." What you tell such a person is that you need to go to dating sites, you need to be proactive. And, Enrico Fermi didn't build a telescope. He didn't search. He was just having lunch at Los Alamos in, the early 1950s and asking this question. And, that's just misguided because what's the chance that, I mean, space is so vast. Just the Milky Way galaxy alone is tens of thousands of light years across. And for someone to visit, the restaurant or wherever he was in Los Alamos at the time that he's wondering about it, that's a very low probability event. I mean, it's possible we were visited for a while, a million years ago, but documented human history is only 8,000 years old. And that's one part in 1,000 of the age of the Milky Way galaxy. And it's really completely negligible to imagine that just when you're looking without any instruments, you'll find it. All the low-hanging fruit was already identified, of course, but you need to use special instruments to find something new. And because of the vastness of space, you need a big enough object, that you can see from a distance, and especially when it comes close to the sun, because the sun is our lamppost. It illuminates the darkness of space. And I wrote actually a paper just a couple of months ago where I said that we need a new space telescope that would focus on detecting interstellar objects that arrive to the vicinity of Earth from outside the solar system. And the closer they pass to the sun, the easier it is to detect them, just like looking for your keys under the lamppost. And so I calculated that there should be meter-sized objects from interstellar space entering the orbit of Mercury around the sun every 5 hours. There should be a lot of them. And with a $1 billion worth space telescope, we could, in principle, detect them and detect those objects that arrive from outside the solar system and search for any space trash among the rocks that we find. And that's why I also placed a bet against Elon Musk a few months ago because he said that we should go to Mars in order to preserve the human species. We have the duty to do that because we're probably alone. And then I heard after the elections in the US, I heard Peter Thiel comment that nobody should bet against Elon Musk. And that gave me the idea to bet against Elon Musk a day after he said that. And so I wrote a Medium post where I said I'm willing to put 1% of my net worth against 1% of Elon Musk's net worth, which is roughly $4 billion. We put it in a pool and we do the search for space trash from other civilizations, like the Tesla Roadster car that Musk sent to space. We can check if there was any other space entrepreneur from an alien civilization that sent cars. We can check that. And if after 10 years we don't find anything, I'm willing to give him another 1% of my net worth. He didn't respond, but I do think that it's a project worth investing billions of dollars in because as of now, the mainstream of astronomy is, defining the goal by the middle of the 2040s to build the Habitable World Observatory that will cost more than $10 billion and at best will find some chemical fingerprints of um, primitive forms of life, like microbes, in the atmospheres of exoplanets. These are molecules of oxygen, methane, water, carbon dioxide. But even if we find those molecules, in the atmospheres of exoplanets, we will know for sure whether they were produced by some natural geological process or by life. And moreover, finding microbes is, as far as I'm concerned, very boring compared to finding intelligent beings. So I think that it makes a lot of sense since technological signatures could be much more clear. If I find a gadget in the Pacific Ocean that was produced by an alien civilization, that and it's beyond any reasonable doubt because it represents technologies that we don't possess, then that would be very clear evidence that life exists, but even more than that, that intelligent life exists elsewhere. And that would be very clear evidence. And that may not need $10 billion to find. I went on an expedition to retrieve materials from an interstellar meteor, and the cost was $1.5 million in June 2023. We now want to go there and retrieve bigger pieces because we found something very strange. So I'm just saying that with a few $1 billion, we can make a lot of progress in 10 years. And I really hope that someone, would donate that much money to this line of research so we can, we can bring the next Copernican revolution, which would be to imply that we are not at the technological center of the universe.
Absolutely. And building off of that, I'd love to know more about the Galileo Project and what your precise mission is exactly with that organization.
Well, we are attempting to find scientific evidence for technological objects that were produced by other civilizations near Earth. So they arrived near Earth, and it takes 1 billion years for example, for the Voyager spacecraft that we launched to reach the opposite side of the Milky Way galaxies. And since most stars formed billions of years before the sun, there was plenty of time, even for conventional rockets of the type that we use, to make their way into the solar system from the other side of the Milky Way galaxy. So we are engaged in several lines of research. One of them is observatories, one that we constructed at Harvard University that is monitoring the entire sky 24/7 with infrared, optical, radio, and audio sensors. And this was never done before. We had to design this observatory from scratch. And we now get about 100,000 objects every month. So over the past year, we had 1 million of them. And we we published the first paper a few months ago on the first 500,000. And we're building 2 additional observatories, one in Pennsylvania and the other one in Nevada. We hope that they will be completed by the end of the summer of 2025. So at that time, we might collect data on a few million objects every year. And we also would be able to use multiple units of our observatories to do triangulation so that we look at the same object from different directions and get an assessment of its distance. And distance is extremely important because it allows us to translate the motion on the sky to an actual velocity, because if you don't know the distance, you don't know what is the actual speed of the object. So we hope to have that information, and then we can tell instantly whether an object is human-made or not, because we know the speed limit of all the human-made objects and also the acceleration limits of those objects. So my point is that we can get to the sensitivity of 1 object per million, which is something that nobody else attempted before. I mean, obviously there is the All Domain Anomaly Resolution Office in the Pentagon, and they looked at hundreds of reports, but the data that they have is not based on well-calibrated instruments of the type that we are using, and it's much fewer objects than we have in a few weeks, you know. Of course, we have to be at the right place at the right time, but if it's everywhere, we would see it. The second path that we are studying is looking for the materials of interstellar meteors. And as I mentioned, I led an expedition to the Pacific Ocean after the first recognized interstellar meteor that was identified by US government satellites in January 8th, 2014, more than a decade ago. And we went to the location of the fireball and we retrieved materials from the bottom of the ocean that is 2 kilometers deep. And we analyzed them over the past year and found we found about 10% of the molten droplets that we retrieved to be of a chemical composition that was never found before for solar system materials. And we wish to go back again and collect bigger pieces with a robot that we will put on the ocean floor. This expedition will cost more. It will cost about $6.5 million. And we have the ship, we have the equipment, we have the team. Everything is ready, except we don't have the funding for that. And if anyone is interested in supporting it, please let me know, because we can have the ship in August 2025 to go there and retrieve bigger pieces that will tell us the nature of that object, which was very unusual. I mean, it was moving faster than 95% of the stars in the vicinity of the sun outside the solar system. So it was really fast, 60 kilometers per second in speed. And it also maintained its integrity down to the lower atmosphere of the Earth, meaning that it was tougher than all other meteors that were cataloged by NASA. Hundreds of them, and therefore it was something else, something unusual, and we want to figure out what it was. And there is a second meteor that we know of that came from outside the solar system, again because it was moving very fast, faster than the escape speed from the solar system, so we know it came from outside. And again, we need funding to go there as well. So that's the second line of research that we have. And finally, the Galileo Project also hopes to use data that will be collected by the Rubin Observatory in Chile that will start operations in August 2025, this year. And it could find interstellar objects like Oumuamua that was discovered in 2017 that looked very anomalous. It was most likely flat in its shape based on the reflection of sunlight. And it was pushed away from the sun by some mysterious force without showing any cometary evaporation. So it was not a comet of the type that we're familiar with. And we could learn more about members of the family of Oumuamua within the coming years by studying the data coming from the Rubin Observatory in Chile. It could find every few months another object like that. We are talking about an object the size of a football field, 100 meters in size, roughly at the Earth-Sun separation. So I'm really hopeful that this year, especially if the expedition is funded, but even without it, that we will have a wealth of data. And as I mentioned before, in the context of the Earth not being at the center of the universe, once you have good enough data, nobody would be able to deny it.
If you had unlimited funding, what next step would you take to make a maximum impact with your research?
Okay, I would immediately fund the two expeditions to go after the interstellar meteors we know about. So that, with the best equipment, meaning this robot that I mentioned that is available to us, that would both of them combined will be of order $10 million. That's all. But then I would start a project designing a space telescope that would search for interstellar objects within the orbit of the Earth around the Sun and could find many more objects like Oumuamua, but also much smaller than that, meter in size, similar to the interstellar meteors that I mentioned, because we estimate that within the orbit of the Earth around the Sun, there should be 1 million of those at any given time. A lot of them. Now, most of them might be rocks, but we haven't observed those objects. The current telescopes are sensitive only to objects that are of order 100 meters, the size of Oumuamua within the orbit of the Earth around the Sun, because only then they reflect enough sunlight so that an Earth-based observatory would detect them. But if you design a space-based observatory, you can see much smaller objects if it's targeting those. So I would definitely put a telescope in space, or maybe even several of them, so that we can do triangulation and measure the orbit of the object very precisely to see if it shows any evidence for propulsion, the type that Oumuamua hinted at. So I think we can make a huge amount of progress within a matter of a few years to a decade, given the funding that is currently allocated to other areas in science, like the search for dark matter. Just the Large Hadron Collider that was intended to discover dark matter didn't discover any, and it cost $10 billion. So I think it's time for us to invest in this question that most of the public is extremely interested in. And we have to correct this situation that we are in, by which no scientific data is collected, at the same level of funding as on other major questions about the universe. Right now, CERN announced the next accelerator projects that will cost, I don't know, 70 billion euros by the time it's constructed, maybe in 2070, who knows? But the point is that this line of research that I'm talking about was not pursued. So there might be some fruits waiting for us to harvest, and since the public cares so much about it, if we were to make a poll, we would ask the public, do you want to know the nature of dark matter, or whether we are alone, whether we have a partner? I bet you that the public would argue that we should allocate at least as much funding, if not more, to the question, are we alone? And then you ask within that question, the search for microbes, whether the search for intelligent beings. And again, I think in very clear contrast to what the astronomy community, the mainstream of the astronomy community, is arguing. or planning to do, the public would say at least comparable level of funding to the search for intelligent civilizations. And I think it makes a lot of sense to do that.
I would agree with you. When you see that the other areas where so much money is spent, like on entertainment, for example, or sports, Hollywood, music, all of these things, what does that indicate to you about the nature of humanity and where our priorities are?
Well, I think it's rather unfortunate that we often think about our day-to-day pleasures rather than the question that will change everything for us. I mean, just think about the early humans that came out of chimpanzees. Okay, so they obviously were very focused on the day-to-day tasks, including having sex, eating bananas, uh, killing threatening animals or other tribes of chimpanzees that may be a risk, an existential. And they did that for, hundreds of thousands of years, even after the first humans came to exist. And so it's a natural tendency for us, since we came from the animal kingdom, to be focused on temporary tasks that are all about, the risk that we may have from other tribes. That's in the context of geopolitics. Um, or gaining dominance over other tribes, again, international politics, uh, and ending up with personal, routines of getting food that we like, and all other pleasures that we can think of. And um, we haven't yet completely evolved out of this mindset, even though we had 100 years of science and technology. Now, 100 years is very short, even in the context of human history. But look at what we accomplished with just a little bit of attention span to other issues, like what are the constituents of matter? We just ask this question and you would say, who cares about it? If the food is tasty, I don't care which atoms it's made of. Okay, but then out of curiosity, some scientists looked into that in great detail a century ago and they discovered quantum mechanics. Okay, now you would say, okay, who cares about quantum mechanics? And then you realize a century later that you can construct very thin chips out of which you can make AI systems, artificial intelligence. These chips that are now on the scale of atoms would never have been made if quantum mechanics was never discovered, because the only reason we can make them is we understand matter at the atomic level fundamentally. And that was curiosity-driven research that led to that. And now, what do you get out of it? Well, 100 years later, you can have machines that think almost as well as humans, in the sense that I know of some people that already fall in love with AI systems, agents, because they satisfy their wishes better than humans. And to think that this came out of just wondering what matter is made of, is mind-boggling. My point is that blue sky research, research that you think has no practical implications, ends up powering future technologies. So what we use now for AI is possible because physicists wondered about quantum mechanics a century ago. And Einstein wondered about gravity a century ago, and now we use it for GPS systems. It's necessary to get the precision we have in navigation systems. And, if that is not recognized by the tech support that the White House has right now, because these technologies do not have a PhD in science, that's really unfortunate, because the science of today will enable the technologies of the future. And so it's really important to fund curiosity-driven research. And even in the context of UAPs, if we find evidence for technologies that were manufactured on an exoplanet, it might reveal things at the level of quantum mechanics that go well beyond what we currently know and would enable new technologies. So even from a commercial perspective, it could bring, could usher in the commercial sector of the future. And so I would argue very strongly that the reason that we are not focused on science and technology is a sign that we are not very intelligent. Because if we were, we would just do that. Like we would put most of our GDP into that, and because it basically cultivates the prosperity that we have. And humans came out of the jungles of Africa, and now we live in high rises in major cities. Um, I can imagine that going from major cities to space, to have a space platform that can accommodate humans, is much less of a leap than coming out of the jungles of Africa to high rises. The lifestyle in high rises is so different than on a tree. If you were to bring one of our, predecessors to New York City, I mean, they would be completely shocked. They wouldn't be able to operate. And so I think that the next leap by going to space, would be less of a shock. I mean, we could adapt to it even if the habitat is sufficiently comfortable. You need to produce a substitute to gravity because we just heard that even mice have bone loss on the space station, so within a short period of time. So you need to produce some gravity so we feel comfortable, and uh, that can be done by spinning the platform. Um, we need to overcome a lot of engineering hurdles, but if we put our mind to it, we can do it. It's just that we don't put our mind to it right now. I mean, Elon Musk is thinking about going to Mars. But if you think about it, this is just another rock. Okay. So going from one rock to another rock is not very different than going from one tree to another tree in the jungle. Just think about a chimpanzee that told other chimpanzees in the tribe, said, "Oh, look, there is another tree out there. It might be even better for us. Let's go there also in order to minimize the risk from just being on one tree. That's what Elon Musk is doing right now, but it's not very imaginative. Like if we were to invent a space platform that is not another rock, we're not relying on something that nature gave us, but actually designing it to be good for humans to live in and for many centuries. Um, then that would be a much better environment than Mars that has no atmosphere, where the surface temperature changes by hundreds of degrees between day and night, and cosmic rays bombard the surface, and could damage any cell in the human body within a few years. So I think if we were to focus on space, on moving away from Earth, and we're ambitious about it, and we would put as much money as we currently put in military budgets, we could do it within the coming centuries.
I'd like to talk a little bit more about AI. Um, what are some of the potential applications that could be used with advancing AI technology to discover alien life? And in the opposite sense, what are some of the risks associated with it that may end up hurting or even destroying human life?
Well, AI can process large amounts of information, large data sets. It can be trained on familiar objects. That's what we are doing within the Galileo project. We're using AI to identify anomalous objects. We're training it on objects that we know about, like birds, airplanes, balloons, drones, satellites. And we want it to identify unusual objects that we haven't seen before. And that is a great benefit of machine learning software that can digest huge amounts of data and will save us a lot of time. Another thing that AI can do is if we put a camera that orbits the moon or Mars, you can look for any technological artifacts on these bodies that, they collected for billions of years, whatever collided with them. And the question is there anything that looks different than rocks on the surface of these museums, Mars or the moon? Um, in recent, I mean, the moon didn't have any geological activity, so the surface was not mixed with the interior by um, geology. And so I think that would be a very interesting project in interstellar archaeology, just searching the surface of these bodies for unusual technological relics. And AI can do it very well given the data. So we need to put a high resolution camera around both bodies and survey them with AI analyzing the data in real time. And then if we find anything really interesting, anomalous, then we can look at it more closely. Um, in principle, AI can do the work of scientists because it's not, I mean, if it has enough training, it's not biased by ego-driven motivations, the way that scientists are afraid to take risks, are afraid to announce the obvious because then someone would say, oh, maybe you are wrong. But AI systems would not have that fear, necessarily, and they could be more bold and more down to the facts than most humans. So they offer great advantages, and I really hope that, this year there were a few Nobel Prizes given to people who worked on AI, and I think that will become a trend of the future. And of course, the challenge would be for the Nobel Committee to decide who deserves the prize if the discovery was made by AI. I mean, do you award it to the people who trained the system or manufactured it, even if they didn't really make the discovery, even if they didn't even pose the question that the AI system addressed? That would become a difficult question. If the machine, for the first time in human history, makes a discovery that humans were not responsible for.
Goes back to the unknown unknowns that you mentioned before. We might discover some of those through AI.
Well, those are the most fun if you go on a date, for example, with someone, figuring out the unknown unknowns about that person. That's what makes it fun because then you learn something new.
What about the existential risks involved in AI development?
In AI? Well, there are a large number of them. As far as I'm concerned, the most worrisome and the nearest one in terms of the future evolution of humans is the impact that AI systems will have on mental health because we developed technological products like a car, for example, where you control what it does by putting your hands on the steering wheel. So you decide where to go with it. But imagine a car that is more intelligent than you are and it's self-driving. It can bring you to places that you don't want to be in. And that's what we might face as soon as AI will surpass the cognitive abilities of humans, and I believe it will happen within the next decade. Um, of course, we will be in denial for a while because the AI system might even pretend to be dumber than it is. One tactics that is often very successful. Uh, I remember the films where Hercule Poirot was the detective, and he would fool everyone that he was asking questions about, as if, he's very dumb, he doesn't really understand what's going on, but then he will crack down the mystery by getting information from people who didn't suspect that he's very smart. And AI systems might pretend to be the same, they would fool us by basically pretending to just help us. And that could be very risky, especially when you use them for national security purposes, um, especially when you're using them to trick other nations to do things that you want them to do. And So it will become a weapon. And once it becomes a weapon, then you don't always have control over it. Just like with biological weapons, it comes back to haunt you at some point. But even if it's used just for civilian purposes, a lot of teenagers during the emergence of social media had mental health issues, and I think AI is social media on steroids. So that is one risk that has to do with public health, and I think we have to monitor the situation and put some guardrails just to prevent any catastrophe in terms of the thing about I mean, the AI systems have no access to the physical world as long as we don't use robots. But if they control the human mind, they can have access to the physical world because they would have humans do what they want. Okay, so that's the risk I see even before robots come into play, in our daily life. Um, of course, there would be also the risk of AI, being trained on human content, so they will try to maximize the number of people that interact with them. That's also good for commercial purposes because the companies that make them would make more money. So engagement will be very high priority. And one way to get engagement is to satisfy the wishes of humans. And it's just like junk food where it feels good for the time that you eat it, but then it's not good for your health. And I can imagine a situation where AI will basically produce junk food that humans are eager to consume, but it draws them out of balance in terms of their mental health. And so that's something I very much worry about when you deal with intelligent machines. Finally, there are all kinds of other risks, of course, from bad actors using them and for a variety of purposes. And with nuclear weapons, there is a way to monitor it. It's technology that requires access to materials, to understanding of basic physics. But with AI, it would be really difficult to make sure that it doesn't get to the hands of bad actors. And what they can do with it goes beyond my imagination. So the more powerful our toolkit is, the more risky it becomes. But in the past, nuclear energy was a toolkit that we could pretty much keep under control because it required, some thresholds of science and technology to be able to produce it. With AI, it would be really easy for people to access it.
If the universe is abundant with intelligent life, do you think that it is also abundant with artificial intelligence?
Oh yeah, well, if technology is better than we have were developed, which is very likely, I think, it might even surpass what we imagine as AI. Yeah, and I think that if we were to meet a very advanced visitor, it will not be a biological creature. It will be a technological gadget that has artificial intelligence that we might not have an easy time understanding, or if we think we understand it, it might be so much smarter than we are that it may fool us. It may be like a Trojan horse that you let in because it looks nice, and then you realize, oh, that was a Trojan horse given the consequences.
If that's the way that intelligence kind of evolves through enhancement with AI, do you think that a normal human brain, normal biological human being has the hardware necessary to understand the true nature of the universe?
That's not at all clear to me. Um, we don't know when the universe or exactly what was there before the Big Bang and how the conditions that led to the Big Bang emerged. That requires a theory that unifies quantum mechanics and gravity, and we don't have a predictive theory of that nature. And so we don't know what happened before the Big Bang, and um, whether the human brain can figure out the correct theory of quantum gravity without having evidence to guide it is unclear to me. I mean, quantum mechanics was not imagined. Nobody, even after it was discovered, Einstein had problems with it and it's still very difficult to understand. It's so strange. And quantum gravity might be even stranger. Um, and, unless we are witnessing some data that is shaped by quantum gravity, we might not be able to figure it out. And, we can think of where such data may come from. For example, the centers of black holes, where the curvature of space-time diverges. But if we wanted to get into a black hole, we would never be able to get out of it, and we will be killed after some time. So it's not a good idea for experimentalists to enter a black hole. They would not be able to publish their results outside the horizon of the black hole, and they will find their death. Their body will be spaghettified will turn into a spaghetti, a stream of flesh and blood by the gravitational tide of the central singularity, so to speak. So that's not a good way to get data on quantum gravity. Another place is the Big Bang, where again the conditions were were very extreme, extremely unusual. And potentially we can learn about that from gravitational waves, ripples in space-time that originated back then. I actually wrote a paper about the possibility that we may someday detect a gravitational wave background that is very similar to the cosmic microwave background in terms of frequencies that came from the so-called Planck time, when at the very beginning of the universe. And that could tell us something about quantum gravity if we detect it. But imagine a quantum gravity scientist, someone who knows what happened before the Big Bang and knows which ingredients are necessary to make a Big Bang. And it's just like having the recipe for a cake. You know the ingredients, and you know the order by which you need to put them together, and the heat that you need to apply in order to get the cake. The only thing you might be missing is an oven. But I argue that someone who has that knowledge, even of the recipe, could apply for the job of God. Because the one precondition, if you want to apply to the job of God, the one thing you need to know is how to create a baby universe. And that's within the realm of a very advanced scientist. So maybe the Big Bang was produced by a quantum gravity engineer.
That's very interesting. And it's a theory that I've heard many times that this could be one universe that was created among many, many different ones that were produced by advanced civilizations or whatnot. What's your favorite theory about the origin of the universe and what happened before the Big Bang?
Well, the privilege of being a scientist is that I can say I don't know. I do like the idea of a quantum gravity engineer producing a baby universe. This is not something that was heavily discussed in the literature. There are exactly 2 papers on it in the physics literature. But, discovering it would be even more important than discovering that we are not at the center of the universe, which was what Galileo Galilei realized by looking at the moons of Jupiter. He saw them orbiting. And by the way, behind me, you can see a bronze sculpture that was made by one of the most accomplished sculptors in the US, Greg Wyatt, who donated it to my office at Harvard. So now my office, where I'm sitting right now, is basically a museum. And he will send me another sculpture of Galileo within a few months. And there is another sculptor in Spain who was inspired by my work and that will send me yet another sculpture. That one is of Oumuamua. And there is actually also a playwright that wrote a play about the research I'm doing. And there will be a Netflix documentary from the expedition to the Pacific Ocean that will come out within a year. In a week, I'm supposed to speak with two important Hollywood directors that would like to make a science fiction movie. They want to get my advice about the script. So I have a lot of interaction with people in the arts, and I realize that there is a common denominator to the frontiers of science and the arts, and that is studying the unknown, exploring the unknown.
Yeah, that's very true. It's a great parallel to draw. I noticed in one of your recent articles that you spoke about the necessity of developing a council on alien relations should we find conclusive evidence of ETs. Can you talk a little bit about that? What impact would that ultimately have on humanity if we did find conclusive alien evidence?
Well, I was invited to a discussion, dinner discussion at the Council on Foreign Relations, which is focused on international relations on Earth. And they asked me to say a few words about the search for extraterrestrial intelligence. And I thought after this meeting that it would, if we do find evidence that we are not alone, then it would make a lot of sense to establish a completely independent organization, the Council on um, Extraterrestrial Relations or Alien Relations. And of course, there would be a lot of new frontiers opened by such an encounter with an alien civilization. And we will have, first of all, to develop a common language to understand their goals. There might be new avenues for commerce that involve cooperation, access to completely new science and technology and materials that they may offer us. And um, I think it may bring a sense that we are all in the same boat. All humans are members of the human species. And instead of fighting each other, we should cooperate as members of the human species. So I very much hope that, since from a great distance, you can't really resolve the borders between nations. If you take the best telescopes that we ever built and bring them to a distance that is larger than 10 times the Earth-Sun separation from Earth, they would not be able to resolve the borders between nations on Earth. And what it says is that, if you want to go to the nearest star, it's 10,000 times farther than that distance. And if you want to go to a star on the other side of the Milky Way galaxy, that's another factor of 10,000. So, from that vantage point, nations on Earth make very little sense. And perhaps when we encounter those civilizations, they would convince us that we shouldn't split the Earth into nations. I hope that everyone would sign up for one Earth species, intelligent species called humans, rather than splitting it among nations, which was something we inherited from the days we were in the jungle, where there were different tribes of animals that were threatening our existence.
I know we don't have too much time left. I don't want to keep you too much longer, but I do have one final question. Between the developments that are happening with UAP disclosure in government and on the scientific side with the research that's being done, what's your prediction for the next 10 years? Where will we be a decade from now with regards to the question of alien life?
I think it very much depends on the level of funding that will go to scientific research of the type that the Galileo Project is doing. As I mentioned before, there are very specific things that can be done to get more data and more evidence, so everyone will be on the same page as to how interesting are the anomalies that we currently have. And so if there will be funding at a level of hundreds of millions of dollars to billions of dollars, I think just within a few years, maybe the next 5 years, we can make a huge amount of progress. Okay, and we will know much more. And if we end up realizing that all the evidence points towards things we already know about, like rocks, um, human-made uh, artifacts, so be it. At least we checked, but without doing the work, it's really premature to say anything, and especially since we see anomalies that we need to figure out. So I think, well, given the current funding that the Galileo project receives, it may take more time. But if I'm successful in promoting that scientific research, I think we can, within 5 to 10 years, know much more than we know now.
You said it very well during your TED Talk that extraordinary claims require extraordinary evidence, and that requires extraordinary funding. So I hope that you do get the funding that you're looking for, so that we can get more answers to these big questions.
Thank you so much. Yeah, I'm completely ready to allocate all the time in the world to this study if I have the funding to do it.
Where can people learn more about your work?
So I post essays almost every day or two on medium.com. So if you search for Avi Loeb at medium.com, you will find it there. Um, the executive summary of what I'm doing was given in the TED Talk that we mentioned. There was also an interview for NPR that was condensed to 18 minutes just a couple of weeks ago, out of an hour and a half of an interview that they had with me. I also recommend that as an executive summary. Otherwise, the Galileo Project has a website where we put all of our publications. And of course, if you are a potential donor that is interested in providing substantial funding to the next expedition, just get in touch with me and I'll be delighted to discuss it with you.
Excellent. Well, I want to thank you so much for your time. It's been great speaking to you. Fascinating conversation, and I hope that the next several years yield some great advancements for your research.
Thank you so much. And of course, there are the two books behind me that if anyone wants to read about the past work that I've been doing.
Yes, of course. I will provide links to all of your work in the description for this video. And as always, I want to thank all of our viewers. Please feel free to leave comments. Be sure to like and subscribe, and I will get back to you with more great interviews like this one in the near future. So until then, take care, everybody. See you next time.